did a really good job of trying it, and actually your whole numbers were correct. It was the variables that gave us a little bit of a problem. So let's go over that one just so you can see, because I do believe I put something like that in your homework. So I want to make sure that you know how to do it. And then we'll go over a FOIL one, and I'll let you try that, and then we shall be done. Okay, so let's go over number 3 that was on your daily log. So it was 4 square root of 3a, and then distributed into 5 square root of 2a minus 2 square root of 12a squared. So when you guys distributed, you did a really good job. So that wasn't the problem. It was the breakdown where we had a little bit of a problem. Okay, so first I will do 4 square root of 3a times 5 square root of 2a. Remember, multiply the 4 and the 5 together. That'll give me 20. And then multiply the insides together to give me 6a squared. Okay, I'll come back to that one in a minute. Now I will multiply 4 square root of 3a times negative 2 square root of 12a squared. So 4 times the negative 2 will give me negative 8. And then 3a times 12a squared will give me 36. 3 times 12 is 36. A to the third. Okay, now after we multiply, we need to simplify. On this first one, the only thing I can do in this radical is I can take out this a squared. So remember, a squared really means a times a. So it has one partner, 1a, that I can pull out of the radical. That's it. The 6, I can't break it down. It's not going to matter anyway. So that's going to stay on the inside. So this radical should read 20a square root of 6. Okay. And then the second one, again, if you notice, ding, 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 math alert, math alert. We have the square root of 36 is 6. So this can come out, and I'm going to bring it out as a 6. So I'll multiply that 8 times 6, which gives me a negative 48. And now I have 3 a's left on the inside. So remember, 3 a's means that I can pull out one pair of partners here. So 1a can come to the outside with the 48, but I still have this 1a that doesn't have a partner, so he's locked up still in the square root. Okay, these are not like terms because the 6 and the a doesn't match in the radical, so this is my answer. Okay, so the multiplying wasn't the problem. It was just simplifying the variables. Otherwise, you guys did a good job with the breaking out the whole numbers. It was just the variables, just forgetting how to do that. All right. Now let's go on to the beastie one. So the very last one we're going to talk about is a FOIL problem. Let me get a new screen here. Okay. So FOIL problem with square roots. So we'll do this as example number 4, even though it's kind of example 3, but since I did 3 already, we'll call this 4. What did I do? Go back, draw. All right, number 4. So FOIL, so we're going to do negative 2 square root of 3 plus 4, and then times 3 square root of 3 minus 5. So now I know I'm going to do FOIL because I have those pluses and minuses. And there's 2 terms in each set of parentheses. So my personal preference, I like to do the box method with these. Just it organizes myself better. You don't have to do it that way, but you can if you want to. So I'm going to go ahead and draw. Okay, Chloe, hi. I'm going to go ahead and draw the box. So a 2 by 2 box because it's a binomial times a binomial. So I'm going to put here at the top, my first term is negative 2 square root of 3. My second term is plus 4. And then on the left side over here, I'm going to put 3 square root of 3 because that's my first term in that new second set of parentheses, and then minus 5 as my second term. So now you're just going to do a multiplication table and multiply these together. So my first box, I would do 3 times -2 would give me -6. And then multiply your radicals. So 3 times 3 would give me 9. So -6 square root of 9. I'm sure you're already thinking how you can simplify that, but I'm going to keep going. I'll simplify at the end. All right, now in this box, it'll be 4 times 3 square root of 3. So there's no radical. It's just whole numbers that we're going to multiply. So that'll be 12 because you're multiplying your whole numbers, and then you just stick the radical on the end of that 12. Because you're still multiplying it, but there's nothing to multiply. So you're just going to stick it at the end of the 12. The same thing will happen here then when we do -5 times -2 square root of 3. I'll multiply my whole numbers. So -5 times -2 gives me a positive 10. And then again, I'm just going to stick the square root of 3, attach it to the 10. And that's all I have to do. Then the last box is easy. I'm just going to multiply -5 times -4, and that'll give me -20. Woo. Okay, now we did the hard work. So the last thing to do is don't forget that we need to simplify. So I'll write that down, simplify, and look to see if you can combine like terms. Simplify. Definitely not a spelling teacher, that's for sure. Okay, simplify and combine if you can. So if you already figured this out, there's only one thing that we can actually simplify, which is this square right here. We know the square root of 9 is 3. So that's the square root of 9 is going to go away, and we're going to multiply -6 times 3, which gives me a -18. So this box is really -18 when I simplify it. So now after I simplified, check, I'm going to look to combine my like terms. Hopefully you're already way ahead of me and realizing that these two are like terms. So now we have to add them. So just be careful because my mind is set on multiplying. So remember, we're adding them. So we just add the coefficients, add the 10 and the 12 to give me 22. Remember to keep the square root alone. You don't mess with it when you add and subtract. That's what sometimes my brain is like, oh, I'm multiplying. Nope, it's adding, subtracting, keep it the same. And then we can combine these two together because they are good old regular.
When do you subtract the like term? Only if it's negative?
Yep, if it was a negative number, Trania, yes.
Okay.
Yes. And then we can combine the whole numbers, like good old fashioned whole numbers. So -18 plus -20 would give me a -38. This is all I can do. I can't combine this anymore because they're not like terms, and that will be my answer. Yay. Okay. So I gave you one very similar to try back on your daily log. So go ahead, if you scroll down to the bottom, there's just one FOIL problem to try. So give that a whirl. And then if we need to go over that one in person, we can do that as well. I'll give you a little bit of time. If you have any questions, feel free to chat me or unmute and ask them if I went too fast or I was not clear on anything. All right, I'm gonna take a minute and go back over the first two examples that I went through when I forgot to hit record. So we're going back to the beginning and talking about multiplying radicals. So our first, our objective for today is that we are going to learn how to multiply radicals. So we did adding, subtracting, now we're multiplying. So the thing with multiplying is that it's exactly the same. Like it doesn't matter what you have. You don't have to have like terms. You can multiply any radicals together. So the first example, I did a basic one of multiplying two radicals together. So 4 square root of 7 times 6 square root of 21. So all you do here, if you notice in the blue, you're going to multiply the whole numbers together, or the coefficients, the ones that are on the outside. So 4 times 6, and you get 24 over here. And then you multiply the radicals together, 7 times 21, which is in the red here, which gives you 147. So that's the only rules with multiplying. You only multiply the outside numbers times the inside numbers. Then the last step is to make sure that you simplify. That's why we practice simplifying first, because if you're taking your ACT or an entrance exam, they're not going to leave it like this. They're going to have you simplify like we've been practicing. So I just broke down the 147. I knew that I could multiply by 7 or divide by 7 because I multiplied by 7 to start. So I did 7 and 21, and then 21 breaks down into 7 and 3. So I can pull out my 27, or I can pull out my 7, and I can multiply the 7 by 24, and that's how I got 168. Again, you can check in your calculator just to make sure you get the same answer. The 3 is still left on the inside because it doesn't have a partner. So my final answer is 168 square root of 3. All right, the second example I went through was just a distributing one. So you're still multiplying here, but this time we are distributing the square root of 6 into these 3 terms on the inside. So we had a question when we started was at the beginning here, this was just a regular square root of 6. And so some, which I'll write over here, some were a little confused because there was no number on the outside. But this is just like a variable. If I give you an x, even though there's no number written on the outside, we know automatically that there's a 1. And it's the same thing with a radical. If there's no number on the outside of the radical, there's an imaginary 1. So that's why I wrote this 1 on the outside. So then when you distribute, you multiply the whole numbers. So 1 times 2, and that gave me this 2 down here. And then 6 times 6 gave me this 36 right here. Then we multiply the square root of 6 times a whole number 3. So again, you're multiplying the outside numbers. The 3 is a whole number. It's not in a radical. So you would multiply the 3 by the 1 and you get a 3. And then the 6 just gets attached to that 3 because there is no radical with the 3. So we're still going to attach it. It's similar to when you multiply, I wrote over here, when you multiply a whole number times a variable, you still leave the variable. 2 times 3 gives you 6x. And you still just attach that variable. Even though the 2 doesn't have a variable, you still attach it on. And it's the same situation with a radical. All right, then lastly, we have square root of 6 times the square root of 10. So the whole numbers on the outside is just a 1. So we're doing 1 times -1, which is just -1 if you want to write that. And then 6 times 10, which is 60. So that's how I got this third one in the purple. The last step is then you need to simplify. So on the first term over here, we should be like having, again, it's easier if you can recognize the perfect squares, and 36 is a perfect square. So you don't have to do all that breakdown stuff. 36, the square root of 36 is 6. So you can just cancel this, get rid of this 36. It's a 6. When you cancel it, you have to multiply it by what's on the outside. So now we have a 12. 3 square root of 6 can't get simplified anymore. So I'm going to bring that down. And then the square root of 60, I just broke down over here into 6 and 10, 3, 2, 5, 2, pulled the 2 out. I have a 3 and a 5 left. So I multiplied those together to get 15. This is my final answer because there are no like terms. They have to be similar radicals in order for you to add them, and you can't. So this is it. All right, if you have any questions, let me know.